All right. Yeah, so thanks for coming to my talk. I'm Lukas from Berlin. I'm working at Snowflake, which is a US-based cloud database company. Previously at a startup called Streamlit, which got acquired by Snowflake. And I will mostly touch on Streamlit in this talk. That's still kind of the project I'm working on. But maybe, let's first start on my topic here, the future of data science and how large language models are transforming the data industry. So I will first go a step back to what I call here the beginning. It's not really the beginning of machine learning, but it's kind of the time when I got involved into machine learning. And what we had back then was those awesome images of bedrooms which you were able to generate with AI. We had like word vectors, and that was like a kind of mind-blowing achievement and back then. And we did a lot of stuff with those technologies, but it did evolve. So we got like better and better embedding techniques for not just words, but sentences, paragraphs. And then in 2017, there was a very big moment on this transition to like those large language models that was transformers. And not the movies, but like this much more amazing architecture based on this paper attention's all you need. So whenever you hear ChatGPT and so on, it kind of uses or is based on this foundation as an architecture, which was written up in 2017. And then in 2020, we got like the first really big language model called GPT-3. It was very kind of also a big thing back then in the tech industry, but it had its shortcomings, so you couldn't really use it for a lot of production things. And one of the big parts is it just, like, in a lot of cases, it just hallucinated some content and so on. So that's not really reliable. And that's basically one of those big steps that GPT 3.5 did, where they were able to improve the reliability of those models. And that's like where we got this kind of explosion of those AI models. And in fact, like ChatGPT, I think it is or was historically seen the fastest growing IT platform. In just 2 months, it reaches 100 million users, much faster than most of the other big platforms we have seen in history. So that's like, it went mainstream. I think everyone probably knows by now, like, or also maybe has used ChatGPT. So yeah, but my talk is a bit more about like how this actually can be used to work with data. And we do have a lot of different tools in the industry nowadays to do that. It starts with Excel, with Power BI. There are like programming languages like Python or script languages like SQL, some kind of dashboards where you can click and select some kind of techniques or statistics like Tableau or SAS. And but it all requires certain special skills. You need to know the tool, you need to know the syntax language, SQL, and so on. So you need to build up some knowledge to use it. And so, and if we take a look on the kind of job of a data scientist, or basically everyone working with data, how like this works in the data industry is you have maybe some form of client, or maybe it's your manager who tells you, hey, I want to have this kind of, I want to have this visualization, this dashboard, or I want to have this result, this statistic, and so on. He goes to the data scientist. The data scientist starts writing some scripts, maybe in Python, maybe SQL, to access the data. And then he starts writing some dashboards and apps, and that's basically, it could be also just a PDF with the results, and that's getting back to the client. But in most cases, the client isn't that happy, maybe have other requests, changes, and it starts again going through the data scientist. He writes, he tries to write those scripts, build the dashboard, and so on and so on. So, and like that's, oh, yeah, that's, I mean, that's kind of the old way. And that's a new way. I should have written here as a new way of working with data science. So, in the new way, people, the developer would just write like a specialized LLM app for whatever data is relevant for this business. And once you have that, all the interaction is kind of between your client and the LLM app, because he can't just use normal language. He can't just use the same language he previously spoke to the data scientist. You can use the same language to speak to this tool, maybe do changes, request other things. So it gets a lot simpler to actually do data science. And that's basically all powered by language. And that's like the big difference. Instead of knowing like those specialized tool, knowing how to use SQL and so on, you can just do your request or request your visualization or whatever you want to know from your data via your local language. And I don't think like those tools probably won't go away, but they will evolve to integrate language as a core part. Or maybe if they don't, they will go away. Okay, so, but how does that actually look like, or if you build an LLM app? I mean, you always have this prompt, which is like requesting a certain visualization maybe. Then you have like a large language model, which can process this prompt. It's somehow, you need to somehow also integrate the data into the LLM request. So you combine the prompt with the data, and then the LLM can give you some results. But there's a big issue, that is those large language models only have a very limited context window. So that are the amount of tokens you can put in, and it can give you give you back. And tokens is a bit like a word, but a bit different. But yeah, in the end, you have a limited set of words you can use. And if you have like a larger data set, you cannot fit that in. So I think like the limits are currently around like between 4,000 to 16,000, something like that. But you usually can't fit in your full data. Though that model will only apply if you're only working with very small data sets. So, and to kind of be able to work with larger data, there's no kind of new trend of different ways on how to approach it. There are vector databases, I will get to that in a minute, but another way you can do it is to not like directly let the LLM give you the results, but let the LLM generate some sort of scripts in SQL, Python, and so on, which then can get the data on the full data set, get a result. The important part is you only give a very small kind of data profile to your LLM so that it knows what it is dealing with, that it's able to generate SQL queries, and though that it also fits into the context window. Yeah, so and here is like a bit more bigger kind of app stack. This is from a very recent blog post from a famous venture capital in Silicon Valley. I think like the only modification I would propose here is like adding Snowflake at a few places. That's missing, and maybe highlighting Streamlit a bit more. So that's like the tool, the open source tool I'm working with. But I think all in all, it's a very good overview on how this kind of ecosystem works. So I will use it for now. And like what I showed in a more simple aspect is getting a bit more technical here. So the contextual data could be anything. It could be documents, it could be a database, it could be images, and so on. You have a way to kind of get them into, like data pipelines, to get them into your embedding models. The embedding models are machine learning models which are able to take on like unstructured data, like or also structured data, but any kind of data like text or images, and create vectors with it. And that's like an important concept in machine learning. Those vectors is like a mathematical representation of the content of an image or a document. And that's, you often, or you have to store it somewhere, and that's like where you do it in a vector database. And then you have this middle part, which is the orchestration layer. This is able to basically use these embeddings, and that's, yeah, right now often based on just some Python scripts. The second step here is once you kind of have prepared your data set, then you go to the prompt construction phase, which means that it could be like two ways. It could be already like the user using your app through queries. You have your app hosting. It goes to your orchestration layer, and that's able to communicate directly with some APIs, like some search APIs to search the internet or something like that. Or in other cases, it could like retrieve data from your vector database, or which is usually then going through like your embedding model and so on. So that's like the flow of information in the system. And then you have this other part here, which is like a lot of new tools coming to the market to improve this experience. So you have validation, which kind of tries to validate whatever your language model gives back, that it's reasonable. You have logging things. You have caching, though you don't do like requests multiple times. And of course, you have those language model APIs like OpenAI. Yeah. So, and now let's go to Streamlit. So how you can build your own LLM apps and how Streamlit fits into this. So first off, like Streamlit is an open source framework. In my opinion, the fastest way to build and share data apps, but legally speaking, I'm not allowed to do that. So it's only a faster way to build your data apps. It's pretty simple. You just write your Python script, and you use some of those Streamlit commands. Like in this case, there's stwrite and stlinechart, and you run your script, and you get a beautiful web app. And the best part is, yeah, it's all free. It's open source. Everyone can use it for everything, and yeah, it's super easy to start. We have a lot of different kind of components integrated, from charts to sliders to file uploads to maps to whatever you need to build your data app. That's available in Streamlit, and you can very easily use it without needing any front-end skills. You just need to know how to write Python scripts. That's basically it. And it's very well integrated with everything you know from this kind of Python ecosystem, like all those more famous visualization libraries like Plotly, Matplotlib, Alter, but also with the machine learning libraries like PyTorch, TensorFlow, and of course, since I'm talking about LLM, also with Hugging Face, OpenAI, Longchain, and so on. So whatever you want to use, you can combine that. And you can basically, with Streamlit, you can build yeah, a lot of different apps. Whatever comes to your mind, you probably can build it quite easily. So, and you don't have to take it from me that Streamlit is a cool tool. Andrej Karpathy, who is kind of a famous guy in the AI sector, he was like the chief of AI at Tesla, now at OpenAI as well. He just, I think 3 days ago, yeah, tweeted that it's like a powerful tool for rapid prototyping, and it's a hammer, so he means probably that you can do a lot with it. And once you know how to use it, you will see a lot of cases to use it. So yeah, that's Streamlit. And maybe let's now go into actually showing it. So it's easy to get started. Pip install Streamlit, that's it. And maybe to start, I will actually ask ChatGPT to generate a Streamlit script. That's also a good part. ChatGPT understands Streamlit, so it can easily generate or help you with Streamlit. So generate a Streamlit app that shows some random data in a line chart. Let's see what it comes up with. he's doing a more advanced version here. It could be done more easily, actually, but he's using caching and so on. But that's fine. So let's see if it was correct. I'm pasting, I mean, I think you cannot see that, but it's not so important. But I'm pasting that in, the stream script. It's already running. I just ran it, instead of running it like a Python script, Python, and then execute the script, you do stream it run, and then it's basically up and running. It's using a deprecated command, but that's fine. And now you have like a chart that's generating some random data. Pretty cool. So you can easily get started. I mean, this script was a bit more complex than it needs to be. So in the easiest way, you just do whatever stwrite. That's just printing some stuff. You save it, and you rerun it, and you have whatever you put in. So that's how Streamlit works. So now we are going back to actually large language models and how Streamlit fits into that, and also like later into data science. So yeah, so with Streamlit we just very recently, or I think we not even have released it yet, maybe tomorrow. We released new tools to actually help you build any kind of LLM-based or chat-based apps. And in the easiest case, that's like here. It's a very easy chat app that just connects to OpenAI. You can ask whatever question, and it prints you out. And that's like the easiest part you can just build in Streamlit for chat apps. But we want to use it now for building, like as I said before, building a more specialized tool that I might give to a client or maybe my manager, so that he can actually do visualizations, do exploration and so on data. And the first thing I'm showing here is this kind of job listings assistant. Though it's connected to a database in the background that contains, like, I don't know, 100,000 of job listings worldwide, and this kind of app lets you explore it. So, for example, I can say filter all job listings from Berlin. So, and he's kind of now working on it. As I said, I'm asking my questions in language. He is understanding what I want. I don't know if you can see that. But yeah, he generated some SQL, and he is giving me back like this table. And I can, of course, go deeper. How many job listings are in Berlin? Again, same procedure. He's taking my prompt, my language, generating a SQL query, and getting me back with the actual results account. And of course, no, he has a full power of SQL here. I can use the full power of language, define anything, and he will try to get that done on the database. So as a next step, that's already nice, but that's only showing you the data. As a next step, what I kind of built yesterday for today's talk is an app I called ChatGPT. This lets you load any kind of data set, so there you can upload a CSV file in this case, or use one of those toy data sets. And I will just load it, and I will zoom in again. So, and what it kind of starts, it starts analyzing the data. First, it only provides me with some overview, but it actually starts looking into the data. And I will get to the point how I communicate that with the LLM model, but he already generates like a description of the data. And he only sees this table. He doesn't have more information than that. But he already kind of starts analyzing the data. He kind of detected, oh, it's apparently about airports in USA, and prints up some more information here. The next thing I requested from the model is that it actually also generates descriptions for every column in this data set. which it did. So and again, it's just his kind of interpretation just from looking at the data. So he tries to come up, name is probably the full name of the airport, the city airport is located on, and then there's latitude and longitude. So that's pretty easy, but yeah, he came up with that. Another thing I requested is that he should give me some interesting observations about the data. I don't know if that's even interesting, but and the last part is, because this app is actually about generating charts or exploring the data with charts. And the last part here on this first message, I requested that he also should generate me with his 4 top charting ideas on this specific data set. So, for example, he's just recommending here just a scatter plot. Let's just try it out. And I have to say, like, all the demos I'm showing are kind of done live. Nothing is faked, so everything can go wrong. Here, I'm also using the faster model, which isn't super accurate. But let's see if it works. So it first starts to kind of analyze. It starts to analyze the prompt, which I just selected, but I can also type in anything myself. And it starts generating code for that. So this is using a library called Plotly, but I can also change that. So supported in this tool are Plotly, Alter, and Matplotlib. I can select whatever charting library I want. And in addition to just getting this chart, it also generates me the actual code. I can now get that code, plug it into my app, my dashboard, or whatever, and I'm done. But maybe I actually don't like it that way. Maybe, though that's actually the chart he generated. It's just a scatter plot, but because it's like latitude, longitude, you can see that it's USA. That are like all the airports that exist in USA. But maybe I actually want to show everything, make it green. I don't know what he understands under make it green, but I think he will do something, put something in green color. Yeah, he did it. So he now is showing everything, make it green. He updated the chart. I just could use language to say whatever I like. But no, maybe I don't like it to be shown on a scatter block. Maybe can you show it on a globe? Maybe I want to have something more like covering the world. So once again, he's getting my prompt, he's modifying the code. We have to wait a second. And, oh, what we have here is a globe, and we can actually kind of move it around. And I mean, I can go on and on and on, modify my things, do other stuff with the data without actually knowing anything about SQL, anything about this programming language, and so on. And I can also then share this as code. Other people can use it. So maybe let's just do another. How much time do I have? Oh, just 30 minutes. Actually, so when there is also a possibility that it will actually generate errors or put in errors into the code. And in that case, this script actually also takes this error and gives it back to the model and says, hey, here's an error with your script, please fix it. And in most cases, it will fix after 1 or 2 attempts. So it's kind of, even if it does wrong things, it can kind of heal itself. Luckily, we didn't get any errors here yet. So, but yeah, let's just use another data set here. It's a Titanic data set. It contains, so I just uploaded it as a CSV. I have it locally. It contains like all the passengers from Titanic back then with information about like which class they were in, if they survived, the age, how much they paid for a ticket, and so on. And once again, I can show the relation between ticket, class, and fare. So I think there should be a very strong relation. Let's see what he does. He's actually also, in the first step, always generating a title, which is kind of nice for my task. And here we go. So you probably see like the first class is maybe the best class, judging from that. So it's apparently a lot higher than the other classes. So you can do those easy things. But yeah, I mean, the important part here is I'm not really communicating. Like, this is not the actual conversation. In the background, it's a much more technical language I'm using. And there's an option to actually show that. So maybe let's start again. So I now activated that I see whatever the system is communicating. We have to wait again for a second to get to that step. Sometimes it's taking a bit longer. Here we go. So we are getting back the same data, but let's actually take a look in the actual conversation, what I'm doing here. So I'm first instructing him. That's like a system method you can give. I'm giving like some context what this ChatGPT or this model should be. So I'm instructing him to be a helpful assistant in describing data, and what the user will do will share some pandas data frame, and this is like where you store data in Python, and he should create some descriptions about the data in a JSON template. So I'm not actually, I want to have like the information back in a form that I can easily parse in my code. So that's why I'm requesting it in a valid JSON. And because, I mean, the model needs to know some information about, or needs to get some context about the data I'm talking about, I'm actually giving him certain information. So first off, I'm giving him all the columns that exist with the kind of technical types. So he knows there's this column called passenger ID, which is integer. And I'm also providing like information about how many values are missing. Oh, maybe that's better. So in the second part, I'm giving him a data sample. So once again, we have the context window. I cannot just put in all the data. That would blow up what it can process. So I'm only giving him maybe 10, maybe 20 samples from the data set, though that he actually has real data to look at. And here at the third step, I'm just generating some statistics. It's again like you cannot really see it quite good, but like it generates like count, mean, average, and so on for all the numerical columns in this case. So it has a quite good knowledge about certain parts of the data. And then again, I'm giving him a specific instruction on how I would like the data. That's a JSON format. And now he's responding. I'm saying explicitly he should only respond in JSON. He shouldn't, the model shouldn't add any other language to it. And that's actually what it does. It responds in JSON. It gives me like, here's a data description for every column. It gives me a description back. That's actually what the model is responding to. The observation and chart ideas. All the things you saw previously. So, and when I'm now going to the next step of, I don't know what that is, a histogram visualizing the distribution of fares across passengers. All right, so once again, we have a different conversation happening in the background to what you are actually seeing in the screen, a much more technical description. Once again, I'm like, in this case, I'm setting up the model with a different prompt. I'm actually saying that he's now like a model that, maybe that's the same. But yeah, I'm once again providing the data. I'm providing not the other part of the conversation. And then I'm requesting that he should generate this code based on Plotly. And I'm giving him the instruction I wrote up. And what it gives me back is this code. No, first off, this is a template code I'm giving him because I want to restrain him from not doing something I don't want. I just want him to fill in this template with the actual chart. So it's giving him more kind of limits, and that's where he's actually should like implement his stuff. Yes, and once again, I'm just getting back the code. That's like the generated code here, the response, which I then can just easily render inside this app. And everything you see here is like it's written with Streamlit and OpenAI. There isn't a lot of other magic involved here, and it's maybe, I don't know, all in all, maybe 500, no, maybe 1,000 lines of code. It's not super, super complicated to write like your own app in this style. Yeah, so maybe at the last part, there's also, I mean, this ecosystem is evolving. In my case here, for this charting app, I just used OpenAI directly. Like you saw all the messages I'm sending in the background. I don't use any other tools to organize the thoughts or something like that. But like there is a lot of things happening in the ecosystem. And one of the big tools is LangChain. And what it actually does is it provides you certain higher level patterns you can use to split up your requests in different sub-requests. So you have different agents who then go there and do some of the work, like searching for data in the internet and then providing the results back to the main agent, and the main agent is using this result to then do some other kind of task. So, and we also have an integration with that, and I can just ask anything here because it's connected to like Google search in a certain way. So, for example, I can ask when was the first Barcamp in Yerevan? So let's see. So what you see here is it's in the background calling different kind of agents, in that case a search tool, a search agent, which is actually doing like a web request with a certain query he does, and then he can extract information from the internet. So he found, I don't know if, is that correct? Does anyone know? 2009? Yeah? So, yeah, he was able to basically complete the task in one jump. The same tool, so I can do any kind of request. I have how many people live in Armenia. Of course, I can probably also go a bit more complicated because probably those tasks are just, no, as you see, it has now decided to do it in 2 steps. So the first one is he just asked for the population in Armenia, and apparently this agent decided that it wants to clarify that he wants to have the population in 2020. So he does another request all by himself. So there is a decision kind of tree going on here, and in the end, it gets me the results. I hope that's also correct. So, but it's not. This tool is not just connected to search. It also is connected to a database, and that's just something I programmed in, or Karen helped me a lot with that. So it's connected to a database about music, about artists, tracks, and so on. So I can also just attempt to actually ask that, and let's hope that he actually is using the database. For example, how many metal tracks, what can I, how many tracks were released by AC DC? I think that should be in the database. Let's see if it, maybe it's using just search, yeah. Okay. Let's specify that. So I mean, yeah, I mean, he can also just search this question. So he decided to not 59 tracks, but let's say from, is it just database? Let's say database. Okay, let's see. So, yeah, now you see it goes another way. He actually has selected this Chinook DB. That's like another tool he has access to. This is the artist database. He generated a SQL query, something we saw before in the other job listing tool. He then got like this back from the database. Apparently there are 6 tracks in this database. It's probably not correct, but I think this database isn't filled with everything. And yeah, and that's what I got back. Yeah, I think that's pretty much it, what I have here. Yeah, once again, you can build all those codes, all those tools yourself with Streamlit. I will have another workshop tomorrow where we go into more details on Streamlit, on technical stuff. It will be more programming oriented for everyone who is interested in that. Join me tomorrow. And that's it. Thank you. And are there any questions? Yeah.
I have a question. Last week I had my first experience with ChatGPT. I didn't really know what to ask, and I asked it, give me the lyrics of a specific song. And it didn't really give me the lyric, it invented it. And when I said, okay, it's incorrect, it told me, yes, but the correct lyrics are copyrighted.
Yeah.
And what happens if you try this?
I mean, I can try it in like just the first step. Give me the lyrics of, what should I?
Well, your favorite song.
I don't have anything in my mind. Of
The Beatles yesterday. Please say that you asked for your grandmother.
a Beatles song.
Well, a particular song.
Okay. I need one name of a particular song.
Yesterday.
Yesterday. Of yesterday from? From who is yesterday? Beatles, okay. Let's hear Yesterday by the Beatles. I mean, I not even know if that's not correct. Is it correct? Okay, I mean, so first off, those GPT models have this big problem of hallucination. And that was like this big issue with those GPT-3 models, where they just, like in a lot of cases, just invented stuff and you didn't really know if it's true or not. That's like the big area where they invested a lot of, OpenAI invested a lot of time to kind of make sure that it stays accurate, but it's still not solved. It still can happen, and that's like also a hard part to get it into production, because there is like a chance of maybe 1% or whatever that it will just invent something. The other problem is with copyright, or even it is trained to stay neutral on a lot of political topics and so on. So it cannot just say what he wants, and there are most likely also those copyright restrictions in there, because it had, like, OpenAI has to deal with like all the laws worldwide. So yeah, I think that's like a kind of evil, or a kind of aspect that you have to deal with those LLM models, and making them maybe slightly worse to be able to run it in all countries. Yeah.
Group of Cambridge University group of scientists have recently found out that the use of model-generated content in training causes irreversible defects in the resulting models, which where tails of the original content distribution disappear. That is, if you train your model, for example, on GPT, this will occur a model collapse. Yeah. How to deal with this kind of questions, the problems?
Yeah. So the question was, since a lot of content will, or more and more content will be generated with those models in the internet, the new models which will get trained will incorporate all those content generated by the previous versions. So it's kind of feeding itself, which is problematic, because in the end it's not any more than based on actual human knowledge, but on self-generated knowledge. And yeah, I think it's a big problem. There was, like, maybe that's what you mentioned with Cambridge. I think there was a study done. There's a big platform from Amazon called Mechanical Turk, where you can do like those micro chops, you get an image and write a description. And I think there was also a study very recently that already 40% of like those tasks are already generated by AI, or not the task, but the response. So people are still doing that on Mechanical Turks, but they don't create their own content. And that is a big problem. I mean, I don't know, I don't have an answer on how to manage it. One way is that those models kind of find a way to get certain watermarking into their text, so that you can detect just based on the text, maybe based on what kind of, a certain kind of selection of how you use the characters or words in your text. That could be a watermark which you can then use to detect that a text was generated. But I think, yeah, we are kind of far from having a good answer, so at least I don't know anything. So yeah, definitely a problem.
Thanks. I just wanted clarification. Is Streamlit similar software to Gradio?
Yes. So the question is if Streamlit is a similar software to Gradio. Yes. So I think Gradio is the one tool. Gradio and Dash are the two tools which are kind of most compared to Streamlit. The difference is Gradio is a bit more focused on actually just being an interface for a machine learning model where you have an input and output, while Streamlit, you can build like more full-fledged interactive applications. And it's like more focused also on data visualization previously than Gradio. Though there are differences, but yeah, you can do a lot of things with both frameworks. Yeah. Any more questions? No? Then, oh, here's one.
My name is Georgi. Yeah, I was wondering, you sort of started out talking about queries being generated in natural language, and the value proposition for that would be that you don't need a technical. The value proposition of generating a query with natural language would be that, like from a business perspective, you don't need to train a more technical person to generate these queries, correct?
Yeah.
But at present, at least, we're sort of not quite there. So how reliable do these queries have to be in order for that business proposition to make sense, for adoption to actually take place? And do we ever get there? Or is the extra effort required to verify the result just not worth it? Because currently, I'm a programmer, so for programming, it just doesn't make sense. And I was wondering if, in principle, these queries that are expressed in sort of mathematical language of SQL, whether it is even in principle possible to express them with sufficient precision in natural language. Is there anything like mathematical on that, or is it just our intuitions that we have so far?
Yeah, I mean, I would say first off, it's super early on that. So, I mean, I am working at a cloud database, like our big thing is. We have a SQL language, people use that. And we are doing a lot of stuff with LLM, but it's all like in the very early steps. So I think, yeah, there is still the problem of you cannot 100% rely on those things. So you need new tools to actually validate stuff and so on. But I think, I mean, you were able to generate those queries already with GPT-3, but the reliability was way worse. So maybe the reliability was at 70%, and now we are at 98% or 95% or something like that. So, and we still have to get that up with better models, with more fine-tuning of those models. So, I mean, everything I showed here were just the default GPT models. They weren't specifically trained to do those LLM things, those SQL operations. So what you can also do is to actually fine-tune those models to be an expert in generating SQL. You start with the foundation model, like GPT-4, you fine-tune for your SQL, and it gets more reliable. So yeah, I think we are super early to tell if it's really now the time where it will switch. But I think like things are looking good. That it will maybe.
And the second part about, is there a known theoretical limit as far as, do we have any math around this issue of like how natural language can just in theory map onto the precise language of, let's say, SQL queries? Or is that something we'll have to discover by experimentation?
So from my just opinion, I'm not a super math guy, so I don't know if people are actively, or I assume people are working on that as well. But I think the issue here is that like those models itself are just mathematics, but they are super complex mathematics. So you have billions of kind of parameters, operations going on. So you can, and there is a lot of effort to understand, to interpret the output, why it was this output, but it's getting more and more harder with bigger models, and it's still not something you really can grasp why it got from this language to this query. So I think, yeah, also on that part, mathematics, I would assume we are super early, and it's getting, like, the models are growing, and I think like the mathematics is hard to catch up, actually, to understand what's really going on.
Okay, let's wait a few years.
Yeah, let's do that. All right. Thank you. Thanks.